Hi, welcome to part 2. Today we're going to be continuing our discussion on how we find relative maximums and minimums, or what we call the first derivative test. Beforehand, we just talked about how we can find out where a function is increasing or decreasing from looking at the graph of the function. But what if we're given the function itself and we don't look at the graph? How can we determine where a function is increasing or decreasing? Well, we're going to find our critical numbers first. That's step 1. We find our critical numbers. And that's what we set up here. So now we're going to actually do the test itself. You might remember that. Where was it at? Oop. There it is right there. Find the critical numbers, and then you're going to make your number line. So if we go down here to find our critical numbers, the derivative will be 6x squared minus 18x plus 12. I want to find out where this derivative is 0, or where does the derivative not exist. And if you're good, you know it's not going to get us anywhere. Where is this equal to 0? I'm going to start right away. I'm going to divide everything by 6. And that's going to give me x squared minus 3x plus 2 equals 0. And if I factor it, I get x minus 2, x minus 1 equals to 0. So therefore, my critical numbers are 2 and 1. And now I'm going to do my sign chart. I'm not giving any endpoints here, so there's no restrictions. Oops, sorry. There's my number line. Put in your numbers, 1 and 2. On top, you're going to put your derivative. On bottom is how does my function look. Now, when we plug into the derivative, it's good to use the x minus 2, the x minus 1, the factor form. And all we're going to do is we're going to pick numbers. We're just going to pick values in between each domain. You did this last year in pre-calc. Give me a number less than 1, like 0. If I plug 0 in, 0 minus 2 is negative. And if I plug into the second one, 0 minus 1 is negative. Two negatives make a positive, so that this is going to be increasing. Right there. So before negative 1, we know the function is increasing. Between 1 and 2, I might pick 1.5. We're not looking for the exact value. If I pick 1.5 minus 2, I know that's going to be negative. 1.5 minus 1, I know that's going to be positive. So that's going to be negative. That's going to give me a negative value right there. So it's going down, like a disco clown. Pick a value greater than 2, like 3. And in this case, they're both going to be positive. So it's going to be going up, like a disco duck. So now I can start looking at this and say, I know where the function's increasing and decreasing. And I can say f of x is increasing on the domain negative infinity, because there's no domain restrictions here, to 1, or from 2 to infinity, because the derivative is positive. See, now that I don't have the function now, but I can still answer the question here by looking at the derivative. F of x is decreasing, so the slope is negative on the domain 1 to 2, and that is because the derivative is less than 0. Now, I can also use a sign chart to help me with other parts about the function. For example, what if I want to find the relative maximum and the relative minimum? Now recall, we said earlier that if the slope changes from positive to negative, we have a relative maximum. So look at this graph right here. Before negative 1, we're going up. And at 1, we're going down. But at 2, I'm turning the beat around again, and I'm going back up. So that kind of gives me an idea of where my relative maxes and where my relative minimums will occur. And I can use that. I can say that my function has a relative maximum at x equals 1. Because I don't know if it's the absolute, because I'm not doing my candidates test yet. But I know it's relative. Remember, for relatives, we only need to change direction. So you can have lots of relatives. We only need to change direction. So we have a relative maximum at x equals 1, and that is because the derivative, what we're going to say, changes from positive to negative. Make sure they're clear and defined there, positive and negative. What about a minimum? Yeah, a minimum says we went from a negative to a positive, and we do that. At 2, we go down, and then we go up. So we can say f of x has a relative minimum at x equals 2. Same reason, because the derivative changes from negative to positive. All right, so now let's put everything together. The whole first derivative test. We want to find out, where is our function increasing? Where is it decreasing? Where's our relative max? Where's our relative minimums? These take a while. So for question number 1, let's take a look here. When we take the derivative, we got this 1/3 x cubed minus x squared minus 3x plus 2. So when we take that derivative, we are going to get x squared minus 2x minus 3. Find your critical numbers. Where does the derivative equal 0? Where does the derivative not exist? Nowhere does it not exist. I can factor. Start working right away. This is x minus 3, x plus 1 equal to 0. So we would get 3 and negative 1. Again, no domain restrictions. My next step, I want to draw my sign chart. Negative 1 and 3. F prime of x and f. And all I'm going to do, remember, I'm going to use my derivative, my factored form. X minus 3, x plus 1. And I'm just going to pick values on each domain. A number less than negative 1, negative 2. Negative, negative. So that becomes 2 negatives, which makes a positive. So we know that this is increasing. Pick a number between negative 1 and 3. 0, negative and positive. Negative and a positive, make a negative. I know that's decreasing. I only want the signs. I don't care what the value is. I just want to know if it's increasing or decreasing. So I only want the signs. After 3, I'll pick 4. Positive, positive, makes a positive. So I know that the function is increasing there. So now I can answer my question. I can say f of x is increasing on the domain negative infinity to negative 1 or 3 to infinity because the slope is positive. F of x is decreasing on the domain negative 1 to 3 because the slope is less than 0. Now, I also need to find out my relative maxes. F of x has a relative max at x equals, where is the slope going? Up and then down at negative 1. So this would be a maximum value. It's like 3 would be a minimum value at x equals negative 1 because the derivative goes from or changes from positive to negative, and we can say f of x has a relative minimum at x equals 3 because the slope goes from negative to positive. Wow, that is like a lot of writing for us to do here. All right, let's take a look at the next one. Okay, hopefully this won't take as long. So we know we got to take the derivative. So I want to find out where this is increasing. This is going to be a chain rule problem, so be careful. F prime of x, we get 2/3 x squared minus 4 to the negative 1/3 times 2x. Don't forget the chain rule. This becomes 4x over 3 x squared minus 4 to the 1/3. Finding your critical numbers. Where does the derivative equal 0? Find your critical numbers. That's just the top. X is 0. The bottom, x squared minus 4 equals 0. That's going to give me plus or minus 2. And so when we go with this, plus or minus 2 and 0, f prime and f. Now remember, there's no vertical asymptotes here, so I'm just going to do my signs. Okay? Let's see how fast we can do this. If I plug this into my derivative, remember 4x over 3 times x squared minus 4 to the 1/3. If I plug a number like negative 5 in, the top is negative, the bottom, this becomes 25 minus 4, the bottom is positive. I know that this is negative right there. Plug in like negative 1. Top again is negative, the bottom, this becomes a negative value, and because that's an odd power, this stays negative, so it's increasing. Plug in a 1, positive over a negative, because 1 over 1 times 4 is positive, the bottom we know is negative. This is decreasing. Plug in something like 3, positive, positive. I know that that's going to be positive, so I know it's going to be increasing there. So I can say f of x, let me write it this way in black. F of x is increasing on the domain negative 2 to 0 or 2 to infinity because the slope is positive. Whoops. F is decreasing. Now notice sometimes I put f, sometimes I put f of x. Either one's fine. On negative infinity to negative 2 or 0 to 2, and that is because the derivative is less than 0. There is a relative max at x equals 0 because the derivative goes from positive to negative, and there is a relative minimum at x. There's 2 of them. We're going down and up at negative 2, down and up at 2, because the derivative goes from negative to positive. See how much fun this is? All right, 2 more. Let's take a look at these next 2. Got to find the derivative, f prime of x, quotient rule, low, 2x minus 1, d high, minus the top, x squared times the derivative of the bottom, all over my bottom squared. Because I have to apply it, I'm going to simplify this. If I distribute the top, I get 2x squared minus 2x minus 2x squared. Those cancel. We're left with 2x over 2x minus 1 squared. Again, find out where the derivative is 0. That's easy. Remember, I'm looking for my critical numbers. X is 0. Find out where the derivative does not exist. 2x minus 1 is 0, or x equals 1/2. Doing a sign chart? 0 and 1/2. The derivative in f. Be careful for this one. We're not interested in the values, just the signs, so don't get panicked. If we plug negative 1, now look at this. The bottom is being squared. So I already know that the bottom is always positive. I just have to look at the top. If I plug in negative 1 to the top, that's going to become negative, so I know we're decreasing. Look, between 0 and 1/2, if I pick 1/4, it doesn't matter. It's positive. It's going up. And what happens if we plug in positive? And he stays positive. Notice, it stays positive here. And if we notice, now we can answer the question. We can say f is increasing on 0 to 1/2 or 1/2 to infinity, and that is because the derivative is positive. F is decreasing on the domain negative infinity to 0 because f prime is less than 0. Do we have a relative maximum? Notice, the slope never goes from up and down. We never go from positive to negative. So we can say that there is no relative maximum. The slope doesn't change like that. But we do have a relative minimum at 0. I can see that. Take a look. It goes down and then up. Now the slope is, something's happening here, but it just keeps going up again. So it's always increasing after 0. But I do have a relative minimum. So we can say that there is a relative minimum at x equals 0, and that is because the derivative goes from negative to positive. All right, last one, trig function. Take the derivative. You can think, man, after that question, trig functions must be nasty. Nah, you can like trig. We get 1/2 minus cosine of x. Find the critical numbers. Where does that derivative equal 0? Where does cosine of x basically equal to half? Well, cosine of x is equal to 1/2 at x equals pi over 3, and what's that, 5 pi over 3? Where is the derivative not existent? Nowhere. So if we do our sign chart, now be careful, we do have a domain restriction here. Make sure you list that out. 0 to 2 pi, f prime and f. Always want to label those, okay? Pi over 3 to 5 pi over 3. There we go. Now, when I'm doing this, watch. Trigs actually aren't that bad because trigs want to oscillate. These oscillate. In other words, they go up, down, up, down. So if I know one of them, I know all of them. So I'm going to start here with pi. Pi is between pi over 3 and 5 pi over 3. But if I plug it in here, I'm going to get 1/2 minus the cosine of pi is 1. So this is 1/2 minus 1. That's less than 0. So it's telling me that this is negative, so it's decreasing. Once I know that, they oscillate. That's going to be positive, and that's going to be positive. I told you, trigs are nice. So now I can answer it. F of x is increasing on 0 to pi over 3 or 5 pi over 3 to 2 pi because the derivative is, increasing, is greater than 0. F of x is decreasing on the domain pi over 3 to 5 pi over 3, and that is because the derivative is less than 0. Relative max and mins, we can do that now. We have a relative max at, look, the slope is going up and then down at pi over 3 at x equals pi over 3, and that is because the derivative changes or goes from positive to negative. There is a relative minimum at x equals 5 pi over 3, and that is because the derivative goes from negative to positive. All right. Hope you guys enjoyed the video. I did. See you soon. Bye-bye.